Hello, my name is Jo Morgan and I am a maths teacher and the writer of the blog resourceaholic.com. Today I'm presenting a workshop that I first did at the LaSalle conference in October 2019 and I was planning to do at the MEI conference in 2020, but unfortunately that has now been cancelled. The workshop is called Calculator Crisis and I'm going to explain why I think there's a crisis and what I think we can do about it. Last year, I took over teaching a GCSE class in the January before their GCSE, so it was pretty late to take on a new class. And they were what we call a borderline class, which means that they were working at, say, a grade 2 or 3, and we were really hoping to get them up to that grade 4 they need to pass and not have to resit the next year. Now, I didn't have much time to get to know them, and this was in a school where students didn't typically bring their calculators. I say typically, I actually mean that no one in this class would ever, under any circumstances, bring their calculator to school. I had a small number to lend, and it was quite a small group I was working with, but I didn't have enough to lend to every student. And as a result of that, I tended to stick to non-calculator topics in my short period of time working with them. However, I was really aware that obviously 2/3 of their GCSE is calculator based, and therefore it was really important that I checked that they knew how to use their calculators. I designed a revision activity, which was basically a revision mat, so lots of questions set out in a grid, and each of those questions required a calculator and it would allow me to see whether students knew how to use their calculators correctly. So I'm going to talk you through some of the interesting answers that I saw when I did this activity, and you can see that it really sounded alarm bells with me. I mean, this activity was incredibly revealing and really made me realise the extent of the calculator crisis in this country. And when I say crisis, I mean the fact that we get a lot of students get to year 11 and just have absolutely no fluency in using a calculator, no familiarity with their calculators, and just they haven't had enough practice over the years. In this presentation, I'll explain why I think that's happened and how I think we can fix it. But before we do that, let me just talk you through some of the things that I saw these year 11s doing. So first of all, I asked them to work out a multiplication of two mixed numbers. Mixed numbers being a number that has an integer part and a fractional part, which are actually added together. And our notation is a bit confusing in this country. Mixed numbers aren't actually used in all countries in the world because the notation is a little bit rubbish, to be honest. If we write 3 followed by a half, in this country, we mean 3 plus a half, whereas actually really that should be translated as 3 times a half. So our notation is obviously not very clear here, but students do see mixed numbers from primary school and they should know in this country that when they see a 3 followed by a half, it means 3 and a half. Okay, so if I'm asking them to do 3 and a half times 7 and 2/5, a lot of my students gave the answer 4.2. Now have a think about where you think that answer might have come from. We can see straight away that answer's nonsense, because if I have a bit more than 3 and I multiply it by a bit more than 7, clearly I'm going to get an answer that is greater than 21. So for them to answer 4.2 makes us think, where on earth has that number come from? Well, I can tell you what they did, and I'll tell you what they should have done. So what these students did, it specifically said use a calculator, and I told them right from the start they had to use calculators for every question. And so what they did was they used the fraction button and they typed in the half, and they used the little cursor to go back before the half and type a number 3. And actually what that does, the calculator interprets that as 3 times a half, not 3 plus a half. So what they've done here is they've done 3 times a half times 7 times 2/5, and that's how they've ended up with 4.2. What they should have done was not use the fraction key here, because the fraction key will not allow them to put a mixed number in, but they should have used shift and the fraction key. If you press shift and the fraction key on a calculator, you can input a mixed number. You get 3 little boxes. You can type the 3 and the half. You can do multiply, and then again shift and the fraction key, 7 and 2/5. And that would have worked, and that would have given them the answer, no problem at all. So this was simply a case of them not knowing where that button is. The students claimed they'd never seen it before. I would expect that this button would be shown to students in year 7, but these were year 11 say they've never seen it before. Now, we can never take their word for it on that. If students say they've never seen something before, often we know that's not true. Students forget things, they see things in different contexts with different teachers, and they can't remember them very well. We all know that students often go to science lessons and claim they've never seen a scatter graph before a week after they've done them in maths. So if they're saying they haven't seen it before, it's not necessarily true. However, it's possible that no teacher has ever taken the time to show them this button. That is possible. The other problem here, of course, and lots of you will be thinking, is that not only do they not know the button, but they've just not used their brains. They've not thought about it. They've not thought, hold on a second, this answer 4.2 is clearly too small. So they've not used their brains to sense check the answer, and they've not known how to use the correct button on the calculator. Here's another example of a question that I expected students to get wrong, which is why I put it in. And in fact, I did see them make the mistake that I expected. So I said that it was a substitution question, and I said if a is -3, find the value of 5a squared minus 2a. So this was substitution. And of the students that were able to understand that this was a substitution question, they all answered -39. Now, we know that this is a common problem with students when they use a calculator to square a negative, that they don't put the brackets in. So when they do their a squared here, they don't put brackets around the -3, which means what they're actually doing is they're squaring the 3 and then they're multiplying it by a -1. If you type in -3 squared, it's the 3 that's being squared because the calculator is following the order of operations. And then we have the negative put at the start, so we end up with a -9 there. Whereas we know that -3 squared is +9 because we understand what happens when you square a negative number. Now, students who just type this in without realising what their calculator is going to do will get this wrong. They don't realise that if you're squaring a negative, you really should be using brackets, or you could do this without a calculator. So it was interesting to see this -39 come up as an answer here, totally expected, and suggests to me that these students had either forgotten or had not been told to use those brackets when squaring a negative. Now, this question again is something that I was expecting them to do the thing that they did, so I was right about the behaviours that I would see in this question. I asked them to increase £43 by 16%. And lots of them used what I call a non-calculator method. They used the build-up method, where they first found 10%, which is 4.3. They divided it by 2 to find 5%. They found 1%. They knew how to do that. And then they tried to add those numbers together to find 16%. And I was really pleased that they knew how to do this. This is actually something that's practiced so much between year 7 and year 11. It's actually a skill that most students are pretty good at, using the build-up method to find percentages. It's actually something that even some of our students that we might worry a bit and who we're worried about passing, this is something they normally can do pretty well. Now, they've done this question in that way, and it would have taken them a little while, but they had a calculator in front of them. And I'm not saying that their answer will be wrong if they do it this way, but the point is that if they have a calculator in front of them, they can do this much quicker, and that means that in the exam, they're saving themselves some time and perhaps with more accuracy, because they're less likely to make a mistake if they know how to do this on a calculator. Obviously, it's fine to use the build-up method, but what I'm seeing here is that they are so not used to using a calculator, they forget they have one in front of them, even if they've used it a minute earlier. They just don't pick it up when they can pick it up. So that's something that lots and lots of teachers are very used to seeing. This was after I did my session on this at MathsConf. I had this tweet that said that this teacher marked the Edexcel paper 2H, so the higher paper last year, and she saw lots of pupils writing out calculations by hand, even though they could have used calculators. She saw column addition, she saw long multiplication. They literally have a calculator on the desk in front of them, and yet they are doing long multiplications by hand. And that to me is just teachers spending so much time trying to get students to A, practice their non-calculator skills, and B, show their workings, that students aren't used to just saying, well, this is one I can do on my calculator. And it's not to say we don't want them to write down what they're doing. We want them to write down their method, but they should be able to use the calculator to do that arithmetic if they are in a calculator exam and they're just not doing it. Another reply to that, this teacher says he saw the same with his students. He finds it stems from not understanding the difference between method and workings. So students tend to write it out by hand because they've had it drummed into them to show workings. So he tries to teach them the difference. So he tries to teach his students the difference between this is what workings looks like and this is what method looks like. If you're in a calculator exam, write down what it is you've typed into your calculator, but you don't have to do it by hand. Whereas if you're in a non-calculator exam, you actually need to be doing your workings there. And there's a difference between writing out what method you're using and writing out your actual workings, which is actually you actually working it out yourself. Another reply to that, on paper 3F, which is a calculator paper on foundation, there was lots of inefficient calculation of percentages. So lots of students who are really confident using that lovely build-up method, they know how to do that, and they're using it in a situation where they could in fact use a calculator and do the calculation in seconds. They're spending, say, 5 minutes doing a build-up method when they don't have to do that. They could do that calculation using a calculator, and that would be the way we would want them to do it in a calculator exam. And like I said before, it's okay for them to use a build-up method unless they're running out of time later in the paper because they're choosing these less efficient methods which don't involve calculators. So let's look at why there is a crisis. So why are we finding that our students at GCSE are not very good at using calculators? Or why are we finding that this is an increasing problem and something that I think is going to get worse over the next few years if we don't deal with it? So the first thing is the removal of calculators from primary schools. So this is fairly recent, the last couple of years this has happened, where it used to be that calculators were used and there was a calculator assessment at the end of Key Stage 2, and now the 3 assessments that students take at the end of Year 6 do not involve calculators. And what that means is it's optional whether primary schools teach them. They know they don't have to teach them because they won't be assessed. And actually that means that they are not being used anywhere near as much as they used to be used in primary schools. In fact, some students are coming to secondary having never used a calculator before. If we have a look at the curriculum for Key Stage 2, it says calculators should not be used as a substitute for good written or mental arithmetic and should therefore only be introduced near the end of Key Stage 2 to support conceptual understanding and exploration. So what the DfE is saying there is please do use calculators because they're a great thing to use in maths for exploring and investigating and all sorts of things, but they're saying they don't want calculators taking the place of written methods. They don't want students saying, oh, I don't have to be able to work this out by hand because I can use a calculator. And the result of that then, like I say, is that we have a lot of students coming to us in Year 7 who haven't used a calculator before. Some primaries are still using them, but understandably some are not. So that's been a big change, and that's something where it's pretty clear to me this year when my Year 7s were all told to buy a calculator. We bought them in from Casio and sold them on to our students through Parent Pay, and they were incredibly excited. Most of them had never had a calculator before. They just wanted to spend some time playing with their calculators. They wanted to do lessons that involve calculators. They still love it now. If I say to them, let's check our answers using our calculators, things like that, they really like having the opportunity to use them just because they haven't used them before. Another thing that is an interesting factor here is I think some teachers assume that these kids are, because they're digital natives, you know, they've grown up with technology, they've grown up with iPads and computers and internet. That means they're naturally going to be very good with anything technological. Whereas actually our calculators are very different to the other technologies that our students use. I mean, you may have seen students first trying to use a calculator by assuming it's touchscreen, particularly graphical calculators. People often assume they're touchscreen. And actually our calculators are quite different. They seem quite clunky and a little bit old-fashioned compared to most tech these days. And our students are just not familiar with using them. We shouldn't assume that they know how to do things naturally. And a good example of that is the shift key. on a calculator, you press shift and then you separately press the button to get the function that is the shift function of that button. Whereas on a computer, you press shift and the button together. So that difference between, you know, when we shouldn't assume that students just naturally know that. I've seen many students hold down shift on a calculator and then press the button. And why on earth wouldn't they not assume that? Of course they would assume it's the same as a computer, because if they haven't been told otherwise, that is a sensible assumption to make. So yeah, they have not seen them before, and we need to know that we're starting from scratch quite often in year 7. I think a lot of teachers haven't been trained or equipped in the new calculators that our students are using. So a lot of teachers may still have their own old calculator which doesn't have the same functionality. If they don't have the same calculator their students are using, then that's not ideal. Ideally, schools should be providing the latest calculators to teachers. Now, obviously, we don't have the budget for that, but really, when there's a calculator that all of our class are using, so the new Classwiz at A-level that came in a couple of years ago, and then more recently the Classwiz that's being used at Key Stage 3 and 4, ideally our schools would buy them for us as soon as that technology comes in, so that we can match up with what the students have got. Similarly, we should be given time for the training for the new technology. So if all of our students have a certain calculator and we don't know how to use it well, then we're going to let our students down, but that's because we haven't been trained in it, and we should be given the time and the resources to learn how to use that technology. As technology changes and as new calculators become available, the gap in between what our students have has widened. So let's have a look at some of the calculators that we might be seeing our students have now. This ranges from graphical calculators through to the kind of very cheap, a few pounds from shops like Wilko, where they which don't have the functionalities necessarily that we need. They are branded as scientific calculators, and perhaps they can do trigonometry, but the order of pressing the buttons is often different to the Casios that we prefer our students to have. So actually what that means is if we see a range of calculators, for example, in any GCSE class, you might see this whole range of calculators now. You might have students who've got those very cheap basic ones which just are rubbish, basically, right through to, you might have even some students at GCSE who have the graphical calculators which basically do a lot of the math for them. I'm really uncomfortable with those calculators because I think they give an advantage to wealthier students. I can't see how anyone can say that they don't give an advantage, because it seems clear as anything that they do give advantages in exams. Some of our GCSE students will have the Classwiz. Perhaps they had an older sibling, the A-level Classwiz. Perhaps they had an older sibling who'd recently done A-level and they've inherited that calculator, and they know that it can help them solve quadratics and things like that, and it can do all these clever things that the calculators their peers have can't do. We would hope that that calculator in the middle there, so the sort of GCSE Classwiz we might call that, we hope that most of our students have that now, so we can have this lovely consistency, every student in the class having that same calculator. So when we use the emulator on the board or when we demonstrate it under a visualizer, all our students have the same calculator. That's the ideal situation. But of course, some of them will still have that one, the fourth one along there, which was the GCSE calculator for many, many years. And anyone who's currently, say, in year 8 who had an older sibling who's used that will have that calculator and not the middle one there, which is the one we might prefer them to have. I will talk in a minute about some of the functions of the Classwiz. But you know, this is the range that we have now, and as new calculators come out, we end up with more of a variety. There probably was a time about 5 years ago, or even less, maybe 3 years ago, where every one of our students would have had that fourth calculator along, that kind of that Casio 85 or 83. Everyone had that, and you knew that if you were demonstrating calculator skills to a class, you know they all had that. But now we have this whole range of stuff going on, and that's making things more difficult. There's also issues with availability in lessons. Certainly we know that in some schools, particularly schools with challenging behaviour, really getting kids to bring their calculator in is pretty low on their list of priorities of behaviour issues that they need to tackle. So if you'll be very lucky if you're in a school where 100% of your students remember to bring their calculator in every day. And some schools will have really good systems in place for sanctioning those who don't bring their calculator in, and kind of ensuring that we have that kind of high levels of students following the rules, bringing their calculator in every single day. Certainly what I find is I have some classes where they're all brilliant at bringing it in, and I might have 1 or 2 students who don't bring it in, and I lend them one of mine. But then I have some classes where the majority of the class don't bring it in, and actually I haven't got enough to lend them. So that's a problem. Wouldn't it be wonderful if we had the budget to be able to provide calculators to students throughout? There are advantages and disadvantages of that. I mean, really, we want them to have their own calculator that they are familiar with, they use at home, they use from year 7 right through to year 11, and they use that in their final exam. That's the ideal situation. But it would also be very helpful if we could have stocks to lend, so that in those situations where we have a class where half of them haven't got the calculator, we can still teach calculator lessons and we don't have to skip over them because we just don't have enough calculators in the room. Another reason I believe there's a crisis and that students aren't familiar enough with calculators is that this big focus on numeracy and this whole, which is brilliant, and of course we should be doing that, but this whole idea of, oh, if we look at GCSEs, they're getting all the arithmetic wrong and they're getting all these really fundamental skills wrong, so let's focus on that. We focus on that so much that we often end up, say in year 11, really not doing much revision of calculator stuff, and we really focus on the that numeracy and then those kind of those written skills. Another interesting thing is people do retrieval starters in their lessons, and the retrieval starters are brilliant, or retrieval in homeworks, or retrieval at the end of lessons don't have to be starters, but people are doing all this lovely knowledge retrieval now, and again, often choosing not to put calculator questions in there just because we don't know if everyone will have their calculator. We don't want to have to mess around with lending them out. So that means that a lot of the retrieval questions we give our students are non-calculator. So we keep focusing on those non-calculator skills, and that means that less and less time is being given to the calculator skills. Another reason there's a crisis is there's been a shift, and I don't believe that we have necessarily as a country, as maths teachers, adapted to the shift. So it used to be that 50% of the GCSE exam was calculator, 50% was non-calculator. We now have 67%, so 2/3, 2 out of the 3 papers in the GCSE are calculator. But yet I don't really think that our teaching has changed to become more calculator focused, even though the assessment has become more calculator focused. At A-level, we are now 100% calculator assessed. It used to be that we had C1, which was non-calculator, but we're now 100% calculator. Now, these changes of assessment shifting towards, yes, you can use the calculator, should really have led us to do more teaching with calculators. But I'm not convinced that we've been that responsive to these changes, and I don't think we've changed the way we're doing our teaching to kind of be in line with the calculator focus in our assessments. Now, I've talked about some of the concerns, the big concern being that our students get to year 11 not fluent in how to use calculators and not confident in using them, and often just forgetting to use them when they have the opportunity. So let's talk about some possible remedies to this. One thing that we need to do as a profession is upskill teachers. I remember when I was teaching the new A-level with the new A-level Crossword for the first time, I didn't know how to use all the functions. I did do a bit of training on it, but then if you have some training on technology and you don't use it straight away, because I had that training in July and then I didn't need it until the September, you do forget these things. So actually there is a need for upskilling and for teachers to become really familiar with these functions so that we can pass them on to our students. Now, the upskilling can be done through online training and through department meetings. So it may be that one member of your team becomes the calculator champion for the department, does the online training or perhaps attends a training course, and then through department meetings disseminates those skills and that information. Now, Pearson has a really good set of training for that for the Crosswords. They're really good courses, very easy to follow, really well laid out, and they just explain the kind of calculator button presses, the key presses that you'd need to solve various problems using the functions on the calculator. So I really recommend those. Now, one function that's quite fun to know about, not necessarily something we definitely need to teach our students, but something that some teachers aren't aware of, is that there is a button that can turn time calculations given in decimals into time calculations or times given as hours, minutes and seconds. So for example, if I typed 2.5 and then use the button that's shown on the screen there, then it will tell me that that's 2 hours 30 minutes. That's a really fun button to explore, and students are often really impressed by it and really excited by it, but often forget it because they're not using it regularly. Now, the buttons like this I think are just really interesting, and they do wow our students, but I don't think we need to worry about teaching them all these sort of little fiddly things that are rarely used. However, there are some buttons that will be used so often that I think they're more important to teach. Here's another example of a button that I think is of limited use, in that we might only use it once in an entire GCSE set of, in the whole 240 marks, and maybe it will come in handy once or even not at all. However, again, it is quite a fun thing to explore, and you can certainly do some fun activities using this button. So this one's the factorisation one, where you can type in any number and do a prime factorisation of that number. So for example, if I type in 1014 and press equals, and then do the shift fact button, which actually is above the time button, then it will tell me that 1014 is 2 times 3 times 13 squared. So it writes it as a product of its prime factors, and that's really fun and really neat. And I remember last year I had some top set year 11s who were working on a question, working on a GCSE paper, and there was a question that asked whether a number was prime, and it was quite a big number, and they took a while trying to work out if it was prime, and I noticed they were doing it in a calculator exam. So I said, well, if you're in a calculator exam and you want to know if a number's prime, you could just use your calculator to do the prime factorisation. They'd never seen it before, and they thought it was a pretty cool button to know about. Again, not sure they'll remember it, because if you don't use these buttons regularly, you forget, but it's definitely something that's worth at least showing them. There's all sorts of statistical functions on the calculator, so things that you can do. So for example, inputting a frequency table and then finding the mean from the frequency table, and various other statistics. For example, the median coming out, and you can see that list of stats there. There's stuff there that's A-level, like the standard deviation. But you know, the idea of getting a mean from a frequency table by just inputting that to the calculator, again, probably worth sharing with students, and it can be part of a whole learning experience. So there's all sorts of ways you can use this to enhance their understanding of mean from a frequency table. We're not necessarily showing them these things to say, oh, this is a sort of way of cheating and just doing it without having to work it out, but this can be part of a way of learning about these things. This can be part of investigations and stuff like that. Here's another one which I didn't know about until recently, and I have not used this one before, but this is really helpful for if they're asked to, say, plot a graph and they have to fill in a table. Basically the calculator can do it for them. So here, if they go to the table mode, and they can type in, using the alpha button, the algebra. So here they've typed in x squared plus a half, and then you can type in the range you want your table to show. So for example, starting at 1, ending at 5, that's your x values, and it will give you the corresponding f of x for each of those x values. Again, maybe not something, we wouldn't want our students not knowing how to fill in a table of values themselves, and I'm not suggesting we'd want them to do that, but these are some functions that a lot of teachers probably aren't aware that the classic, the standard GCSE calculator can now do. It has a ratio function, and this is something that's just worth knowing about. It can be used for all sorts of things: ratio questions, unit conversions. Basically, when you have an equality of ratios, you can use it to find a missing value. So you'd go to the menu, you go to the ratio function, and here you can see, for example, 1 to 2 equals x to 10, and it will work out what that x is for you. This is the sort of stuff you can play around with in lessons, and it's just worth knowing. Teachers need to know that these functions are there. Particularly, sometimes you'll have a student who'll say, "Oh, Miss, how do you use this function?" And we want them to know that we understand these calculators that we're asking them to use. These are just some of the examples of the numerous functions that that not all teachers know about, but do exist on Casio calculators, and are really worth having a play with. So as well as upskilling teachers, that's one of the things that needs to be done in this country to help solve the calculator crisis. There are also various initiatives happening or that schools can do. For example, MEI has done quite a lot of work on calculators. Last year they did this wonderful competition called Calculator Crunch, and it was aimed at students in year 6 and year 7, where they set them daily challenges that just involved using calculators. They were challenges that you could use a calculator to help you with, and they were a really nice set of activities and really really sort of thing that was a great timing at the end of the summer term, and was really engaging for students. Say for example year 6s after their SATs could all have a go at this lovely activity. Some schools, I'm told, do calculator licenses. So it's similar to in primary, where they might get a pen license. Once their handwriting is good enough, they can stop writing in pencil and start writing in pen. Some schools in year 7 set children a test on the calculator skills. They teach them the calculator skills and they set them a test. And then if they pass this test, they give them their calculator license, which means, hey, you're allowed to use your calculator in maths from now on. Presumably you'd want everyone to pass that test because you have taught them the skills, and you don't want some people not being allowed to use their calculator. But it is quite a nice gesture, something quite nice to say to the students. Congratulations, you are now allowed to use this calculator in mathematics. It's quite a nice idea. As well as initiatives, there needs to be a lot of deliberate teaching of calculator skills. So this means lessons on, today we're going to look at some calculator skills, or perhaps it means just weaving activities involving calculators throughout our normal lessons, or perhaps it means setting aside time for calculator revision before exams, not just in year 11, but each year when we come to those assessments, spend some time saying, right, let's make sure we know how to do these things that involve calculators. The most important remedy for this whole situation is for teachers to embed calculator use from the start of Key Stage 3. And that means right from the beginning of Year 7, maths teachers making an effort to have those calculators appear in lessons as much as they can. I've really worked hard on this year. I'm teaching a Year 7 class where if I can let them, say, check their own answers using a calculator, then I will, just because I want them getting really comfortable and familiar with it. So I'm not asking them to do complicated stuff on the calculator, but I am asking them to use them for checking. Sometimes we'll do activities that involve calculators, which I've put in just because I'm really conscious that I want them all to be very comfortable with calculator use. I have many times taught Year 7 and not done a single lesson that involves a calculator, and I'm trying very hard to do it differently this year. We do have some things to be aware of here. We have to be very careful not to have too much calculator use. There's a balance to be had. This American teacher is warning that before students learn how to do addition, subtraction, multiplication, division, they have calculators, and that means they never understand the basic concepts. And because they don't understand the basic concepts of arithmetic, because they have calculators, that means that they then don't learn the things that's necessary to understand algebra. Remember, understanding how to do arithmetic leads us on to understanding algebra, and is absolutely necessary. So that has led to problems in the United States where they have calculators almost maybe too young, or too much calculator use in place of becoming fluent in arithmetic methods. So that's an interesting thing to bear in mind. We could also look at some of the research that's been done and some of the opinions, because it changes all the time, and this is really interesting. This was an article that said children are over-reliant on calculators in maths lessons, and this was about the time when the calculators were removed from primary assessments. This was the sort of debate that was happening at the time. The argument was, ministers were saying that children have poor math skills because they're over-reliant on calculators. I'm not 100% sure that was the reason that there was a numeracy issues. I don't think it was necessarily the calculators that were to blame. But this article, which was from 2011, so this is quite a long time ago now, 9 years ago, they were saying that children can't do basic sums because they have calculators. There's an interesting correlation causation thing there. I'm not 100% sure you should blame the calculators for the fact that children can't do the sums, but that was one of the arguments at the time. Fast forward 7 years and we have headlines like this: calculators can build children's math skills, research suggests. So it's like we've come full circle on that argument, and we have now research suggesting that, hey, we should have more calculator use. So I think perhaps we went too far with the removal of calculators at primary school. Children's math skills are not harmed by using calculators in the classroom, according to the academics at the IOE and University of Nottingham. This is really interesting because this seems to really contradict that earlier research which says that we need to get rid of them because they're ruining everything. The article here says that while primary school students shouldn't be using them every day, secondary school students should have unrestricted access to them. Now, there'll be some topics we teach, like for example, if you're teaching a lesson on surds, there's limited use in students having a calculator because you need them to learn how to do that without a calculator. In lessons on fractions, some lessons actually work well with a calculator, and some lessons you just don't want a calculator being used, because what's the point in teaching students to add fractions if they just put them all in a calculator? So unrestricted access, it really just means that there are often times where it's fine to use one, and actually angles is a good example of that. If a student's working out the value of angles in angle problems. So say we have a triangle and two angles are provided and one angle is missing and students are having to work out the missing angle. Why not let them use a calculator for that? That's a brilliant opportunity to use a calculator, because the arithmetic is not what you're testing and shouldn't really be relevant there. Of course we want them to be good at arithmetic. Of course we want them to be able to add those two numbers. Of course we want them to be able to subtract from 180. But actually, if you want to teach them and assess their understanding of angles, then don't get hung up on the arithmetic. Let them use a calculator. And there are quite a few topics like that. I mean, another interesting one is index laws. If you've got something like x to the power of 5 times x to the power of 13, and your student can't figure out what 5 plus 13 is, that's a concern. But however, if you're trying to teach them index laws, why not use a calculator to add 5 and 13? Okay, maybe that's a bit of a silly example. Maybe we want some bigger numbers there. But the point is, we shouldn't be holding our students back from progressing in maths because they have weak arithmetic. We separately work on their arithmetic, and then we let them use calculators in order to understand and access other topics like geometry, for example. We need to get the right balance. And if you look at these two articles, which are totally arguing from opposite points of view. So one is saying too much calculator use is a big problem. The other is saying actually calculators aren't a problem at all, and we should let children use them. We need to get the right balance. And I'm not saying that we should be at one or other end of the extremes. I think that we maybe have gone too far away from calculators. And I think it's something we need to move back towards the middle a bit more. So I'm going to talk you through some resources now. I think there are 3 main types of calculator activity or resources that are available. First are resources for practicing mixed calculator skills. So this might be something you use in a revision lesson, or you might say, well, we're going to do a lesson where we're going to just play around with calculators today and we're just going to do some mixed stuff. So these aren't anything to do with specific topics. And like I say, these might work best as revision. Have a look at this one. It's from MathsPad, which is one of my absolute favourite websites for resources. This is an odd one out. Now, this is quite interesting because I feel like I want to look at this and try and do it without a calculator. But actually, if you want them to practice their calculator skills, this is a really lovely activity. So, for example, if you look in that first row and we're saying which is the odd one out, they're going to type in both of those calculations, and one of them will match 1.7 and one of them will not, and that one will be the odd one out. So there we're testing whether they know how to do a root symbol over a fraction, which is really testing just, do they know where those keys are? Do they know how to use the cursor? All that kind of thing. And this is a really lovely activity, and it really sort of tests that just general, do we know how to get the buttons right, the key presses right on a calculator? So it's a really nice one. Teach It Maths has a calculator skills progress checker. This is a great activity because I think could be something that you could use for the calculator license I talked about earlier. So if you decide you want to test, say, your year 7s and whether they're good enough at using a calculator in order to give them this calculator license certificate, then maybe they could complete this. So you can see that what's quite nice is that it asks them a bit about the maths as well as how to use a calculator. So for example, question 2A, calculate the square root of 529. Question 2B, what's the name of that button? So they need to know that that's a square root. If you look at 5A, calculate 3 plus 4 times 5, and then 5B, why is the answer not 35? And you want the student to realise the calculator is following the order of operations. That's a really nice little assessment, and there's some good opportunities to use that to check where a student's calculator skills are currently standing. I expect if you gave this to a student at the beginning of year 7 now, they would be able to do pretty much none of it, whereas a few years ago they might have been able to do a fair amount. There are also, so they're sort of general, there's all sorts of resources that are mixed calculator resources. If you go to resourceaholic.com, my website, and go to number, there's a section on calculator resources with loads of stuff like that. If we look at resources for specific topics, again, there's loads of those. So when you're teaching a topic, you could think, well, is there a way I can bring in some calculator skills with this? So this one is from Teach It Maths, and this would be maybe if you're teaching mixed numbers. This is just a quick activity. This is not your whole teaching of mixed numbers. This is just something that could come into one of those lessons as a nice activity to have a play around with the calculator. So here you can see the students will put in, for example, the improper fraction 9/2, and then use a calculator to turn that into a decimal, and then to also turn it into a mixed number. We've got the SD button on the calculator, and also the Shift SD button that a lot of students don't know about. And those two buttons are incredibly helpful for moving between these three representations, and these buttons are probably used more than anything else. And it's really, really important. You know, you quite often get students who are familiar with using calculators, but their calculator gives them an answer, say square root, and they want to know that answer as a decimal. And of course, they need to know to press that SD button. So they need to be so fluent in using that. Activities like this are really helpful. So I would use this in teaching a lesson on mixed numbers. And it's not my main activity. It's just something that I would have them do, perhaps even at home, because I'm happy for them to use a calculator. So this would actually make quite a good homework. This is another one from Teach It Maths. I actually used this one recently when teaching powers to my year 8s. It's a crossword. It doesn't need to be a crossword. It is set out in a crossword, and it's quite engaging. The clues all involve using a calculator and using either a root or a power key, and that means that it's testing really well. Like for example, look at that 10 across. They have to do a cube root of a large number. There's no way they're doing that in their head. They'll have to get it from a calculator, and they have to know. I mean, cube root's interesting because quite often you get students who type a 3 and then a square root, which is actually just doing 3 times the square root, and instead of knowing that they can use they can do a cube root, and that 3 can't just be sitting in front of it like a multiplication. That 3 needs to be up the top there in the index. So it's really worthwhile to get them to play around with this, just to make sure they know how to use those powers and root keys on their calculator. That went down really well with my students when we had to go. The only thing they got a bit stuck on was 1 down and 17 across, where it uses the word palindromic, but it gave me a nice opportunity to talk to them about that. Now there's lots and lots of other things for topic specific lessons, but now the main thing I want to talk about is where we can use calculators just in our normal teaching. So I'm not doing a calculator lesson, and I'm not saying, hey, now we're all going to practice calculator skills, but just in the course of my normal teaching, I do something where it's okay to have a calculator, and I can bring the calculator in, and it just becomes something that's just part of my standard lessons. It's part of my routines. So we're going to look at resources for understanding maths, which it's fine to have a calculator for. Now, a lot of these I've got out of old resources. It's interesting that these resources, you know, this is from a long time ago. I got this from STEM Centre, and they're great resources, but they really don't make stuff like this anymore, perhaps because there's this assumption that everyone knows how to use calculators, which is absolutely wrong. So as far as I know, no one's making great resources like this. I would love it if someone made a resource for the new Classwiz, which was a book of calculator activities to use in your normal teaching, which will really help our students get to know their new calculators. At the moment, we're using these pretty old resources for this kind of thing. Now have a look at this example. This is if I'm teaching place value, which is a great place to use calculators. Now this can be done without a calculator, of course. We don't need to use a calculator, but the fact is I'm saying to my students, you may use a calculator, and that means they probably will because they like using them. This is a number line activity, perhaps if I'm teaching decimal place value. You can see in that first one there, I'm asking if the number line goes from 0 to 1, what's the value of A, what's the value of B, what's the value of C, and what's the value of D, and then they'll write all those in the boxes and they'll check whether they're right by typing those numbers in and adding them up, and they should get a total of 2. So the point there is they're just using their calculator to check an answer. And the calculator is not teaching them place value, but the fact is that I'm saying it's okay to use a calculator. It doesn't help them cheat. It doesn't give them any advantage in working out the values of A, B, C, and D. It does help them check their answer, and then they know they can move on to the next one. If they got it wrong, they can put up their hand and ask me. So that's really helpful for self-marking. But also it means that they're just getting used to the fact that, hey, I've got a calculator on my desk, I'm just going to quickly check this answer, which is a really important thing for them to check, to do on a regular basis. In every lesson, it's an important thing to just reach for that calculator. Here's another example of a calculator activity. Again, these are really old activities that I found on STEM Centre. So this one is perhaps more of a primary activity, or for students coming in Year 7 who are struggling with writing and reading numbers. So here, one student will read out the words. So they might say 256. And then the other student will type that number in their calculator. So in order to get this right, they need to know what that number looks like in digits. So the student will read out all the numbers in set A. The other student will be typing them in and will add them up. And hopefully, if they type them in correctly, then they'll get the answer 8,601. So what we're checking, and if they got it wrong, it means that they don't know how to type those numbers into the calculator. So for example, the number 6,081, does the student know what that number looks like? You know, thinking about it, my daughter who's in Year 3 would probably love this activity, and it would really help me to check whether she knows what these numbers look like, because something like 6,081 is something that she has to really think, you know, what's going to go in each place. What's going to go in each column to type that number in. So this is a really nice little game and a way of checking that students know how to type these numbers or what these numbers actually look like. Here's another activity which is similar. So this one, they are given a number in figures. They write it in the box. So we are saying, what does this number look like in digits? 100,000, how many zeros will that have? What is that going to look like? And then they use their calculator to do 160 times 625, and then they write down what that says, and what's in the two boxes should match. So again, this is just practicing writing numbers. This is something that could be used at primary school, or perhaps for students who aren't confident with this in Key Stage 3. And the calculator bit is just a way of checking that it's still getting them fluent at using a calculator, which is something that we need to do more of. Another example here, I think these are really fun, I like these. This is to do with, again, place value, multiplying and dividing by powers of 10. In question 1 there, they start with number 5, and we have to say, what do we do to get to 0.05? What do we have to do to number 5? And they have to write down what they think. So here it's divide by 100. And then they use their calculator and they put 5 divided by 100. Oh, look, 0.05, they've got it right. Now let's try the next one. How are we going to turn that back into a 5? We're going to have to multiply by 100. So again, we're going to type that in our calculator to check whether it's right. So the calculator is being used as a check. If that becomes a culture in your classroom of calculators being used to check rather than to cheat, then that is something you want to establish. You want that classroom culture of, I've done the maths and now I'm just going to quickly type that in to check. Like that's what we need. I've done this one with my daughter before. Again, she's in Year 3, and I'm getting her used to calculators at quite a young age, because I don't want her to be in a situation where calculators are totally foreign to her when she starts secondary school. This was really perfect for her in Year 3, because she had just been learning about this kind of how to do these kind of questions. So here you start with the 300, and then you type into your calculator, take away 1, and it gives you 299, so you know you've got that right. And then you say, right, next I need to go from 299 to 199, 199. So what am I going to have to type in my calculator? So she looked at it and realised that the hundreds value had changed. So she said, I'm going to have to subtract 100. So she typed, she wrote minus 100 in the little flag, and she typed it in a calculator, and she was really pleased because it gave her 199. So it's a really lovely activity. There's 3 different activities there, 3 tasks, and they get progressively harder. Like I say, really great for primary school, and also for your students who lack confidence with this sort of thing in Key Stage 3. So place value is a great topic for you just using calculators all the time. In fact, there's loads of topics that are great. Here's another opportunity topic. So fractions, decimals and percentages, we can use calculators all over the place here. Not just for, say, percentages using multipliers where we definitely want to use calculators, but also just in general in developing understanding. There's some activities where it's just helpful to have a calculator to hand. So if you look at this one, which is a percentages activity, we're saying 35% of 60, and we have to write the approximation in. So we're saying I think that's around a third of 60, so I think the answer is going to be 20. And then we say, well, if I want to use a multiplier for that, I'm going to type in 0.35 times 60 on my calculator. And that gives an answer of 21, which is close to my approximation, so I know my approximation made sense. Now, there's quite a lot going on there. That's quite a more advanced task than some of the others I've shown you in terms of percentages, fractions, and decimals all in one place. It involves students approximating, so using their brain, and then they're using a calculator to check their answer, and then they can compare their approximation with the calculation they've done. I think that's a really lovely activity. Just bear in mind that when you do the 0.35 times 60 on a calculator, you could also use the percentage button there. So you could type in 35 and then use the percentage button, which again is something that most students just don't really use very much. Here's another one that could be used for decimals. This is a really nice activity for developing that understanding of adjusting calculations. So here, if you know that 8 times 91 is 728, and you get that from your calculator, then they're saying, well, what will 8 times 9.1 be? And we should realise that's going to be 10 times less than 728, so we can write down 72.8, and then we use our calculator to check whether that is actually right. So that's a whole series of questions on multiplying by decimals by adjusting calculations. And I really like how the first one they do on the calculator, then they try and figure out what it's going to be when they've adjusted it, and then they check on the calculator. I think these are fantastic activities. They all come from these really old resources on STEM Centre, and they're all really worth having a look through. And like I say, I would like to see these activities kind of modernized. You know, at the moment these are taken from old scans, so the quality of the scans isn't always brilliant. I think this is perfectly usable, but you know, it would be nice to see kind of modern resources along the same lines as this. This was a question in a non-calculator paper back in 2017. It was a higher GCSE paper. It was question 15, so about halfway through the paper. And it gave 4 fractions, 1/6, 1/7, 1/8 and 1/9. And it asked whether they would give recurring decimals. I thought this was a really interesting question, because when the exam finished and I looked at the paper, and I thought, I'm not sure my students would have got that, because in terms of recurring decimals, all I'd really done with them was the proof. So they knew how the notation worked for recurring decimals. They understood dot notation, and my students knew how to prove the equivalence between a fraction and a decimal using an algebraic proof. But they didn't know, I'd never really spent time talking to them about how we can look at a fraction and know whether it's recurring or not. I'd never done that, and perhaps that was me missing something that I should have been teaching. So with this question, I thought, well, I know a 9th and a 6th are recurring, and I was pretty sure that a 7th was recurring, and then I thought about it, and I thought, well, an 8th, well, I know that an 8th is half of a quarter, so I know an 8th is 0.125, so actually I know that one's terminating. So that means that, yes, I can work it out, but it still really made me think. I've never told my students a rule for this, and if they were given a more complicated set of fractions, would they have known how to tell by looking at it whether it is recurring or not? Now, interestingly, I found an activity for exactly this, and I found it in this wonderful book, School Mathematics with the Desk Calculator. I wasn't really sure what it meant by desk calculator, but the book explains that this is a desk calculator. Now, I'm afraid this is from before my time. This calculator certainly has never made an appearance during my time at school. I went to primary school in the 80s, and I don't remember seeing anything like this, so I think this is a bit before my time. It's funny that's called a desk calculator. It's pretty big. I suppose we went from desk calculators to what they then called pocket calculators, and pocket calculators are more similar to what we now use. So this was not for a pocket, but this was for a desk. And this book, which is about using desk calculators, happens to have a brilliant activity for investigating recurring decimals and how we know whether a fraction will give a recurring decimal. Now, this is the activity it suggests. So if you have a look at this, we've got the fraction 20 over 24. They have factorised it, written it in as a product of prime factors, so that gives us 2 times 2 times 5 at the top and 2 times 2 times 2 times 3 in the denominator. And then the law of cancellation. Now this is really interesting because I've never really thought of cancelling fractions by writing them as products of primes before, so this was really interesting to me. So we cancel the factors of 2 that match on the numerator and denominator, and that gives us 5 over 6 in simplest form. So we've got 20 over 24 is 5/6. We knew that, but this was an interesting way of looking at it. And then we look at the denominator, and the denominator has the factors 2 times 3. And then when we put in our calculator 5 over 6, we can see that it gives us a recurring decimal. So when the factors in the denominator are 2 times 3, our decimal is recurring. And then we look at the next one, and we end up saying that when we have a 3 times 5, so when we have a 15 in the denominator, the decimal is recurring. And then we try the next one, which is 3/10, and the denominator has factors 2 times 5, and that one is terminating. That is not a recurring decimal. And the interesting thing here is we can go through and try this for a whole load of fractions, and we can try and figure out what is the pattern, what is the thing that makes a fraction a recurring decimal or a terminating decimal. What's the difference in these denominators that we have to notice? Now, at this point in my presentation, which I did last year at a LaSalle conference, and I was going to do this year at MEI, this is the point where everyone tries this activity. Some of you will already know what the rule is, so how do we know what sort of decimal are we going to get from a fraction? But some of you will be discovering this when you do this activity. The activity is available on TES because I've typed it up and here it is, and this is what I handed out during my session everyone had a go at. So if you want, you can pause this video now and have a go at this activity. For those of you who don't want to do that right now, it will end up looking very similar to the grid I just showed you, and then we can try and spot the pattern. This is a lovely activity because we can do all this without a calculator, and then that very last column where we have to check the kind of decimal, that's where we reach for our calculator. So this is an activity where the focus is not the calculator. This is not a how do I use a calculator activity, but it's an activity where the calculator just comes into it, and it's just the calculator is part of doing the maths. Now, if you've done that, some of you may have paused the video and done that activity, some of you may not have done it but have just had to think about it. There's a few things that are really lovely about this task. One is that it's brilliant for sort of interleaving lots of different ideas. So here we have decimals, fractions, we have primes, and we have factors. So it's really nice when we can do some prime factorisation in a lesson where we're not specifically teaching that, because that's great for retrieval, kind of bringing that back in. It perhaps gives students a deeper understanding of fractions. I really like that idea of cancelling by writing things out as prime factors, and then we realise that when we cancel, say, a 4, we're actually removing the common factors of 2 on the numerator and denominator twice. I thought that was really good for sort of deepening that understanding of what's going on when we simplify. This task is a discovery task, which is not normally the sort of style of task I give, but I think this is a really clear discovery task, which is nicely structured, easy for students to follow the instructions and start to notice for themselves what the rule is. So they're really discovering for themselves what is it that makes a fraction into a recurring decimal or a terminating decimal. They're gaining some new knowledge, so they're learning something new. They're figuring it out themselves, but not in a kind of very roundabout, convoluted way. way. You know, it's pretty clear and pretty succinct, like how this fact comes out. Finally, they're developing some calculator skills, which is a nice aside. Maybe they're not learning anything new on the calculator, but they're just practicing with it. They're just using it, which is something we want to get them used to doing. Just for those of you who don't know what the rule is, this is taken from that book, that desk calculator book. A fraction produces a recurring decimal when the denominator contains any factor other than a 2 and a 5. And that's once you've simplified it. So if you've got a simplified fraction and the denominator, if it only contains 2's or 5's or a mixture of 2's and 5's, then it will terminate. But if there's any number other than a 2 or a 5 in the denominator, in the factors of the denominator, then it will recur. So for example, 1/6 is 1 over 2 times 3, and the fact there's a 3 in there, that's what makes it recur. Whereas 1/8 is 1 over 2 times 2 times 2, and it's only got 2's in it. If it's only got 2's and 5's or 2's or 5's, that means it will terminate. So that's a really nice bit of knowledge and something that for some reason I'd never told my students before. So the answer to our question here is 3, because we could do a quick prime factorisation of each of those denominators, and we could see that only one of them has just 2's or just 5's or just a mixture of 2's and 5's in it. The others all have numbers in the denominator, factors of the denominator that are other than 2 and 5. I think that was really interesting, little fact that I'd never thought about, and it was interesting that this question kind of made me realise that that's something that I'd not explored with my students. I want to just show you one more activity just because it's related to what we were just looking at there. This again is from some of those old books on calculator activities, and here it says make a list of the calculator versions of these fractions, and I can only assume the calculator versions are the decimals, because if we write down the decimals for these fractions, then we do start to spot patterns. So for example, in question 2 it says investigate the pattern of 1/7, 2/7, 3/7, what we're noticing in those decimals, and it's saying that we should recognise things like 100th, 200ths, 1000th, 2000ths. It's saying that we should these are things we should recognise the decimals of. So this whole thing, you're basically using your calculator to work out these decimals and just spot the interesting patterns and the things that goes on with the equivalent decimals. The activity then goes on to investigating all sorts of other fractions using your calculator, and I quite like question 5 here. So it says 0.93333 recurring is not one that we'll recognise, but it is made up of 2 fractions from the list we've just made. We can see that it's 0.83 recurring plus 0.1. And we know that 0.83 recurring is 5/6, and we know that 0.1 is 1/10. And we know if we add those together by adding fractions, we get 14/15. So that's one that we wouldn't recognise, but it is a combination of 2 that we might recognise. And then we use our calculator by doing 14 divided by 15, and that will give us, or that's on an old calculator. We have other ways of doing that in a modern calculator, and we can check that in fact that is 0.93 recurring. And then they give us some other examples to have a play with, and they're made from two fractions from our list. And I think this is really nice. Like for example, 0.85. I might think, well, that's 0.8 plus 0.05, and then I can figure out what those decimals are equivalent to. I can add the 2 fractions together and then check on my calculator whether I was right. I think that's a great activity. There are loads of activities like this. Those calculator books from STEM Centre are absolutely full of them. And what I like about them is this is not a lesson on how to use a calculator. It's a lesson on exploring fractions and decimals, and we just happen to be using our calculator to help us along the way. I'd love to talk about this with people. I'd love to know what schools have been doing to try and improve calculator skills and calculator fluency amongst their students. There may be some schools where this isn't a crisis at all, where it's done really well, and year 11s are coming through being really confident and comfortable using their calculators. I think it's a nationwide issue caused by the various factors I've talked to you about, but I do think that there are pretty straightforward remedies, ways that we can fix this. But really, one of the things we're relying on is those Key Stage 3 teachers to really do everything they can in terms of bringing calculators into their lessons more than perhaps they had to do before, because of all these factors that have changed in the last few years. So we really need to sort of make a concerted effort to have those calculators as an integral part of our maths teaching. I hope you've found that helpful. I hope you found it interesting, and thank you so much for listening.